Hey class, today we're going to look at rational numbers. So by the end of this lesson, you will be able to identify terminating and repeating decimals, convert fractions and mixed numbers into decimals, and convert decimals to fractions and mixed numbers. First, what are rational numbers? A rational number is any number that can be written as a ratio A over B, where b is not 0. So when we say that a rational number is any number that can be written as a ratio, that's basically a fraction. Any number that can be written as a fraction, both positive or negative, is a rational number, as long as your denominator is not 0. Because if your denominator is 0, you're going to get an answer as undefined, right? We can't divide by 0. That is no good. Okay? So rational numbers can take the form as fractions or mixed numbers, and that makes sense because a rational number is a number that can be written as a ratio. So a fraction already is a ratio, and a mixed number, if we make it improper, is then a ratio. Other things that can also be considered a rational number are terminating decimals. So those are decimals that end, and we'll talk about that a little bit more shortly. And repeating decimals. And repeating decimals are decimals where the digits repeat, and we'll talk about that a little bit more in detail later on. So let's think of some examples that are considered rational numbers. So it's anything that can be written as a ratio or fraction. Well, whole numbers can be written as a ratio because if we take the whole number 3, we can do 3 over 1, which is a ratio, which is the same thing as 3 because 3 divided by 1 is 3. So whole numbers count, negative whole numbers count, any type of fraction, both positive and negative, count. You can do 0 counts, 0 over a number counts, right? You just can't have 0 in the denominator because we cannot divide by 0. We get an undefined solution. All right, so all of these things are counting as rational numbers. Most numbers can be counted as a rational number. The exceptions are things like pi, because that decimal, it doesn't terminate, it goes on forever, and the decimal part, it doesn't repeat in a pattern, it's all random, so that's not considered a rational number. All right, so like I said, rational numbers, they can be whole numbers, fractions, decimals, and specifically terminating and repeating decimals. So let's take a look at how to convert rational numbers from one form to another. So first we're going to take a look at how we convert a fraction to a terminating or repeating decimal. So any fraction can be written as a decimal by dividing the numerator by the denominator. So remember, numerator is the top number and denominator is the bottom. So in our example, we have 1 over 40 or 1/40. So we can make that fraction, which is a rational number, into a decimal by taking the numerator 1 and dividing it by the denominator 40. So 1 divided by 40. And now we're going to have to do some long division to get our decimal answer. So we're going to do 1 divided by 40. Well, 40 goes into 1 0 times, so we need to put our 0. And now we're already going into our decimal, so we need to put our decimal in. And then we can annex a 0. Now 40 goes into 10. Again, 0 times, so we're going to have to keep going and annex another 0. Well, 40 goes into 100. Well, 40 times 2 is 80, so it can go in twice. And then 40 times 2 is 80. Now I'm going to subtract 100 minus 80 is 20. Wrote that in the wrong spot, 20. And now I'm going to bring down my 0. And 40 can go into 200 5 times. So I'm going to put a 5 up there. And then 40 times 5 is 200. subtract, and I get 0. So that means I am finished. The decimal is what we call terminated. So 1 divided by 40 is 0.025 or 0 and 25 thousandths. And because we got a remainder of 0, our decimal terminated or ended. So this is actually called a terminating decimal, which is a decimal that ends or whose repeating digit is 0. That is called a terminating decimal. And terminating decimals, like I said before, are a form of rational numbers. So any terminating decimal can be considered a rational number because, like you see, we could convert it into a fraction, right? This terminating decimal, 0.025, as a fraction or ratio was 1 over 40. All right, let's look at another example. So in this example, we have 11 over 18, which is again a rational number because it's in the form of a fraction or a ratio. Now we're going to see how we can convert this ratio or fraction into a decimal and see what type of decimal it is. So 11 over 18 is 11 divided by 18. So again, we're going to do our long division. So 11 divided by 18. 18 goes into 11 0 times. So I need to put my 0 and then add my decimals to keep going. I'm going to annex my 0 to get 110. And 18 goes into 110 6 times. So 18 times 6 gets me 108. Now I'm going to subtract 110 minus 108 is 2. Now I need to bring down my 0 because I'm not done. So now 18 goes into 20 once. 1 times 18 is 18. Subtract, and I get 2 again, so I bring down the 0. So 20 and 18 goes into 20 once, and this is going to keep happening. This is never going to end. It's going to keep being 1. So this decimal is going to be 0.61, and the 1 is repeating. So when a digit repeats, or a set of digit repeats, we call this a repeating decimal. And a repeating decimal is also considered a rational number because, as you can see, it can be written as a ratio. This repeating decimal was written as 11 over 18. So a decimal that repeats a digit or a set of digits is called a repeating decimal, which we just got. The digit that repeated in this example was 1. Repeating decimals can be written using bar notation, which is that bar that I put over the 1 up here. That's bar notation, so that I don't have to keep writing 1, 1, 1, 1, 1, 1. In bar notation, a bar is drawn only over the digits that repeat. So only over the digits that repeat. So the only thing that repeated here was the 1. So I put the bar over the 1 and not the 6. So our example was 0.611111, and we just write it as 0.61 with the bar only over the 1, because that's the only digit that repeated. All right. Okay, so now that we know what terminating and repeating decimals are, let's try sorting the set of rational numbers between terminating and repeating decimals. So our first one is 1.222222, and the ... means it goes on forever. So this rational number is considered a repeating decimal. So I'm going to put that there. Then we have 0.3455, and it stops. So that is a terminating decimal, but it is still considered a rational number. Remember, all terminating and repeating decimals are considered rational numbers because they can be written as a ratio. Next, we have 5.400000, and the zeros repeat. So although we have a digit that is repeating here, the digit that repeats is 0. So since the digit that repeats is 0, it's actually considered a terminating decimal because we could just rewrite it as 5.4 without the repeating zeros. So that's a tricky one. Next, we have negative 2.645454545, ... So this is a repeating decimal. So we're going to put negative 2.6 and then the 4, 5. The 4, 5 are the digits that are repeating. So we're going to put the bar over the 4, 5 only. All right, so again, terminating and repeating decimals are all considered rational numbers. Terminating decimal ends. Repeating decimal has a digit that repeats or a set of digits that repeat. All right, so now that you know how to convert fractions to decimals, I want you to go ahead and try number 1 and 2. You're going to convert the fraction to a decimal by dividing, and then you're going to tell me if it's a terminating or repeating decimal. When you have a whole number like you do in number 2, you're just going to leave it out so you know your whole number in the decimal number will be negative 2, and then you're going to do your 7 divided by 9 to get your decimal part. All right, try that on your own. The video will pause, and when you're ready to check your answers, hit continue. All right, take a moment, check your answers with mine. So the first one was a terminating decimal. The second one ended up being a repeating decimal. If you got something different than I did, take a second, pause the video, try again, and then check your work with my work, see if you found any mistakes. All right, so we're going to stop here on this back side of the notes, and then we're going to do some practice with this tomorrow. And then we will do the rest of this note page on Monday, so do not lose it and make sure you have it on Monday, because on Monday we're going to continue and start looking at other ways we can write fractions and mixed numbers into decimals, so some easier ways sometimes. And then we're going to look at converting decimals to fractions. All right, so have a good day.